Good morning, everyone. My name is Craig Overmiller, and I will be the instructor for this project that we're working on between US and India. And I have several PowerPoints. This session, session 1 and session 2, are PowerPoint. Session 3 will actually be a design lab, and we'll be in the upstairs lab for that particular session. And so let me share the screen. Make sure our sound's on. And all right, let me get my picture out of the way. And we're ready to start. US-India Water Pumping Partnership. I'd like to welcome Hindustan Institute of Science and Technology and the Sri Ramakrishna College of Arts and Science. And then I'll be representing Alamo College District. And my name is Craig Overmiller. I'm the Program Director of Power Generation and Alternative Energy. And I'm part of the Allied Construction Trades Department. So this is our course introduction, and it is called Session 1. And so as we move through these different sessions, there'd be several of them, close to 15 or something like that. And they may or may not be in order. And each session will look at a different area of water pumping. And so we'll have several topics, lots of different topics. And then I also want to divide the course up into systems. And the systems will be the energy system, it'll be the water pumping system, it'll be the vertical, and then it'll be the horizontal water pumping, and then we'll have the storage, and then we'll have pressurization and sanitation, and for the water itself to make it potable. So we'll go on through. Let's start with our first slide. Well, I thought that was a good spot. There we go. Coursework and scope. So this training will consist of multiple media presentations of Zoom and YouTube, as well as other media formats. The purpose of the presentation is to share an understanding of water pumping technologies between our two nations. There will be 15 main topic segments. They're going to be, it says 2 hours each, but that's going to vary quite a bit. These first two sessions are only an hour each. So, and that's going to vary, like I said, depending on the content. These segments may be broken down into smaller segments and subtopics. And because of film location changes, we'll be, right now I'm in the classroom. Session 3 will be in the lab. And then starting after that, we'll be out in the field if it ever stops raining. We've been having it's been raining for a month now straight here in San Antonio, Texas. That's where I'm located. And it's just been crazy, 2 inches of rain every day. We're gonna be looking at water well pumping equipment. Methods may vary between our two countries. And so the course description is Train the Trainer water well pumping course. This will be an in-depth tutorial on material, equipment, and methods of training and installing a shallow water well of no more than 200 feet. When we go out into the field, I'm going to show you some wells that we have and some pumps that we have, submersible pumps that are capable of pumping 1,200 feet. And so the one that we have is pretty small, and we'll see that on the next session. And so the course will include well design, well terminology, installation, and horizontal and different types of water pumping designs and water treatments. So we'll have design theory and application, such as what, when, and how. The following lists are the topics to be covered, and we'll expand into the specifics, including in each module. So topics may change to better meet the local needs as we're working on each one of these. So topic 1 or module 1, water well theory and design. Number 2, material takeoff and delivery. Job site analysis and prep. So I can already tell you we're going to be doing session 2 will be after this one. This is the intro. And so I already got a few things out of order there. Job site analysis and prep. Module 4, drilling well and casing. Number 5, surface pump versus submersible pump. Number 6, install. Number 7, install. Number 8, install. But, you know, install will be going along the whole time as we are working on these different topics. Module 9, DC pumps versus AC pumps. Number 10, single phase versus 3-phase water pumps. Above ground cisterns and why, which is basically water storage. And then solar and battery storage. Module 13, surface pumping. Number 14, pressure pump and pressure tanks. And 15, water storage and purification. Pretty important part right there. We don't want to get anybody sick. So water theory and design. First, you want to look at your site location, the site conditions and geological surface and subconditions, water table depth and gallons per minute, recharge versus discharge. Your well has to recharge faster than you're discharging it, otherwise it'll go dry. And then also, when we're looking at geological surface and subconditions, things like that, here in Texas, where I'm located, San Antonio, Texas, we have satellite maps provided by the Conservation Office, United States Conservation Office, and the State of Texas Conservation Office. And they actually can spot water from satellites, you know, where's a good place to be drilling. And so that's kind of good to have. Head and head pressure, you know, head is basically the height that you're pumping, but the further up you pump, the pressure gets greater and greater because water weighs a lot. And so you got a 1-inch column of water that's 200 feet long, and you're trying to pump that up out of the ground. You got to calculate the weight of that water. And so that's what creates the pressure. Drilling methods, we have rotary, we have jet water or compressed air. We also have what's called a cable tool, which is basically an impact where we just pound a hole into the rocks. Compressed air or water jets, we just blow water or air into the ground and drill a hole that way. And rotary, which is kind of the standard that everybody uses, that's that big truck with just a big auger bit that's on the back of it. And it just goes round and round and round, and it drills a hole until you get to where your water is. So then we have the different types of pumps. We have piston pumps, diaphragm pumps, helical pumps, etc. There's different reasons for using different pumps in different locations, and different pumps also have better pressures and greater depths. We have submersible pumps, which goes down inside the well. We have jet pumps, which assist the submersible pump. We have a surface pump, also known as a transfer pump, and which helps push water in a horizontal direction. And then we have pressure pumps that allow us to pressurize the water and move it through a piping system. Types of energy that we'll be looking at on this particular project. We have AC current, and we have AC volts and amps. We have DC current, which will be in volts and amps. And then we'll be looking at single or 3-phase power. And then we'll look at bore casing and then post-drill sanitation. A lot of times when you drill a well, the well bit is contaminated. And so it had drilled a hole somewhere else in the local area, and it hit water that had bacteria in it or had some other type of issues. And then when you go to drill your new well, you're bringing along and you're contaminating the new well with whatever you brought up out of the old well that you had drilled previously. And so it's just like when we go to Mars or the moon, we got to make sure we don't take anything with us so we don't contaminate the new planets that we're trying to colonize. Uh, Water storage, that's kind of a big thing. Um, Sometimes I like using a enclosed cistern. Sometimes the water storage is also in an open tank, especially for livestock. And then here again, we have water purification. That's what we got to look at, different ways of purifying the water. And is the water for human consumption? Is it for livestock? Or is it actually going to be for both conditions? And so usually, if it's for livestock, you really don't have to purify that water. So we might have, two different systems going in two different directions, one for humans and one for livestock. Excuse me. Material takeoff and delivery. That's an important one. I'll show you why here in a little bit. Shop or construction drawings, which are blueprints, drawing, understanding, and interpretation, construction schedule, and having a timeline, list of your equipment. And so I'm going to stop share for a second. For some reason, my video went off. All right, we can go back to share screen, go back to where we were. And all right, now we're back. For some reason, my cameras just went off on me. All right, material takeoff and delivery. That's where we were. List of equipment, vendor identification. You know who your vendors are, so that you know who to buy your equipment from. And then we have shipping, we have transportation. Then we have to have receiving. The big thing about receiving is inventory. I mean, you got to check all your equipment in. Site storage, protection, and security. And then what are all the required tools and manpower that we're going to need? So the reason material takeoff and delivery is very important, especially on the receiving end. We received what we thought was a 24-volt inverter. The box said 24-volt inverter. But when we opened it, it was a 48-volt inverter inside a 24-volt box. But we've gotten that all situated now, so at least we have the proper inverter and we can move forward with our installation of our equipment and our build that we're going to be doing. Job site analysis and prep, and this is where job safety is real important. Know your government rules and regulations for doing a water well. We have lots of them here in the United States, especially here in Texas. You can't just go drill a well anywhere. You have to get permits and have drawings and have, sometimes they want a test well drilled first, all kinds of different things. Know your site geography, and site geography is, the soil conditions and geological substrates you're going to run into. You're going to have rock, gravel, sand. The location where we're going to be at is nothing but sand. You can go down 1,000 feet and you're still going to be in sand. The reason for that is because here in San Antonio, we used to be under the ocean, and we got a huge sand bed here now when the ocean retracted. Know the well location. Survey if it's required. Geological maps. One of the things too you want to know are the existing wells that are near you, because you're going to be competing against them for recharge. Satellite images if you have them. We got some good satellite images of the property that we're going to be looking at. Government studies and surveys of what the water tables are and in your area. I recommend security fencing, one, to protect the job site from third-party people walking on and getting hurt, and also for protect all your equipment that you spent so much money on buying. Things disappear, and so it's always good to have everything secure. Personal protection equipment, PPE, is what we call it. That'll be your hard hat, your gloves, your safety goggles, vests, that are nice, bright colored vests people can see easily. And then, of course, what's real important, and it's always nice to have, is the job site manager. Job site manager's job is to make sure everybody's doing what they're supposed to be doing, and that the people, the labor, the material, and the tools needed for that day are all in the same place. All right, drilling well and casing. There, like I said, we had talked about the different drilling methods, the different types of drilling machines. We have the rotary, which we discussed, which is the truck that just drills a hole straight into the ground, and it has a drill bit on it. The water jet or compressed air is just that. It's a water, pressurized water. It's on the end of a nozzle, and that nozzle is on the end of a drill bit, or not a drill bit, but a drill rod, and it just goes into the ground, and the water jet just blasts the hole all the way into the ground. Compressed air is the same thing. A cable tool, which is impact. Impact driver just pounds a hole into the ground, and then by hand. And that's actually how we drilled the well that we're going to be looking at when we go out to do our install. Know what the depth of the well is, and then, like I said, we'll be down about 200 feet. We have 200 feet of poly pipe for our well. Types of casing. Are we going to use steel casing? Are we going to use PVC? And sometimes people use clay as a casing. And then the casing depth, is the casing going to go all the way to the bottom of the well, which is 200 feet? Doesn't necessarily have to. A casing filter, which is at the bottom of the casing. And it's a filter that allows water to come into the casing, but keeps out all the sediment so that they don't fill up the well and impede our water pumping. And then the depth of the water pump. So you always want the depth of your well to be about 25 to 50 feet further down than the location of the water pump. And the reason for that is, like I said, is for sediment and to build a water reservoir. And then we're going to have to look at, our head and head pressure. The head is the depth, and the head pressure is the weight of the water. And so how far are we going to be pumping water up out of the well? That's called head. Surface pump versus submersible pump. Well, what is a surface pump in types? The surface pumps, there's a lot of different ones. There's a jet pump, there's a transfer pump, and there's a pressure pump. And so we'll be using a transfer pump and a pressure pump on this project. And then what is and then those are used for going horizontal. Once you're up, got your water up and out of the ground, you switch to surface pumps and pressure pumps. What is a submersible pump and types? Well, we talked about all those before. A submersible pump is the pump that actually goes down into the well. And sometimes they're 3 or 4 wire, depending on if it's going to be a DC or an AC system. If it's a DC system, it'll be a 3 wire. It'll be a negative, a positive, and then it'll be a ground. And then if it's a AC pump, it'll be a 4 wire. You'll have the two hots because it's going to be a 3-phase, and then you'll have a neutral, and then you'll have a ground. What's the purpose of the different pump types? Here again, it's how far down are we pumping? How much water do we need, gallons per minute? And then what is, are Are we going to be going horizontal? Or are we going to be going vertical? Moving water vertically is, you need a pretty heavy duty pump to be able to do that, and one that can push water straight up out of the ground because water weighs a lot. And then moving water horizontally, here again, we talked about those different types of pumps. And then we'll have water storage that allow us to sanitize our water. And then it also gives us a reservoir and creates a little bit of pressure for us because water weighs so much. And so we have a good sized tank. We'll automatically have water pressure in order to push that water through the water lines that are going horizontal. Weight of water, here again, that's the head and the pressure. Creating water pressure. So you have two different ways. You can use gravity. Here in the United States, especially in the cities and neighborhoods, we have water towers. And so we pump water up and fill up this huge tank that's on top of the tower. And then just the weight of the water itself and gravity creates the pressure that we need. And so most of the residential neighborhoods and commercial projects are between 50 and 75 PSI, pounds per square inch on our water systems. And then you also have mechanical. So we have a pressure pump, and our pressure pump will get up to 80 PSI, and our pressure tank that we'll be using can get up to 150 PSI. But we're not going to be going anywhere near that high, I don't think, on our pressures. A solar pump or grid power pump. So we have a DC solar pump that will be ran by 2 solar panels, 200 watts. And so we'll have those in parallel since they're at 24 volts already, so we can build some amperage. And then we'll also look at some grid power pumps, which are DC pumps. And so it's just what you're looking at, on whether, depending on what kind of power supply you have, where you're located. Amount of energy are needed is in amps. Pumps like voltage, so we got to make sure we got our voltage, and then the pumps themselves will have a pump controller that will regulate the volts and the amps so that we got the proper watts that we're going to be needing to move the water. All right, installation. The installation of the water well will be several segments and possibly be blended with all the other different segments that we're looking at or sessions. And we'll be ongoing through all of the topics. And so as we talk about our topics, we'll be looking at all the different things as we're actually doing the installation, and they'll all blend back and forth together. And now here again, we look at the purpose of the well. Is it for humans? It's going to be potable, or is it going to be for livestock? And that's going to, determine how much, or the different types of equipment and the different types of piping and things like that we're going to have at our particular job site. What different equipment is needed for the different purposes? We'll look at all of those different things. Filtration and sanitation for both. Filtration just keeps the water clear. Sanitation makes it drinkable. And so we want to make sure we have both of those. It's got to be pretty. It's got to be for human consumption. People don't like muddy water. Evolution of the well as installation progresses. You'll see how the well builds and all the different things that get added to it. First thing we're going to do, we're going to build our electrical system. Now we got to have electricity in order to put this well together. And then we're going to be adapting as we work, and everybody has what's envisioned, what we think it's going to look like, but what it actually winds up looking like versus is the applied. And so I have my idea of what it's going to look like, but once we get out in the field and we start building this, it may change. And it probably will change. Somebody will have a better idea of how to put something together than me. Installation. So we got to plan the install. And so we'll be doing that here in just a little bit. And we're going to be drawing on the board behind me. We'll be drawing the entire layout of the system and how it's going to look and what we're going to be needing. lay out the site. So once we get out to the job site, we'll get that laid out. We got to have a work area, and temperature here gets kind of brutal, and so we'll probably have a tent set up, just a shade covering that we can work under when we assemble things, and then have plenty of water on site, for bottled water on site, since we're trying to make water, just to keep everybody hydrated. Material delivery. The way we're going to be materials already been delivered here to the college, but I still going to have to transport that out to the job site, which is a ranch south of town. And then once we get out there, we have to inventory the equipment, make sure everything's there, and then lay the equipment out as it's going to be installed and used. So we got to look at that, plan the sequence of events, and plan the sequence of our work, how it's all going to go together. And then we got to create a good work environment, which is what I was talking about. The grass is pretty long out there. I'll try to get it trimmed down before we work. But also, you know, with the shade, the tent shade will make things pretty good for us while we're working. Develop a safety plan, and develop a construction schedule. And then we just got to make sure we have all the different tools we're going to need, because it's a long way back to the shop to go get tools if we don't have the tools we need already. Okay, here again, still on installation. Equipment orientation. We're going to have a particular process of flow, water process. And so how we set up our equipment and install our equipment will follow along that process. And water separation based on purpose. Here again, we're going to go in two different directions. We're going to go for, we have cattle on the property, and so, and goats. And so we'll probably be taking one to a surface tank that allow for the livestock. And then we'll also be having we have a 500-gallon cistern where we'll be taking and purifying the water and filtering the water for human consumption. And so that'll be our storage tank. And then power supply. At the location, we have both grid power, and we will have solar power, because we're going to build our own solar power. Grid power is already there, but I don't want to use that. I want to try to do this all with solar. And so the construction power will be our solar. So that'll be the first thing we're going to build, is our solar power system. And then we have solar modules, which are the solar panels, energy storage, which are batteries, and then we have our inverters. And so that was what I was talking about. We were supposed to get a 24-volt inverter, but they sent a 48-volt inverter, but they've already switched it out for us. Real nice people. And so now we're able to proceed with our training and our installation. So water treatment, we're going to be looking at two different types, chemical, and well, we got chemical, UV, and ozone. So there's actually three different ways that we can treat the water. Ozone is what most of the big water treatment plants here in Texas use. Nothing really survives ozone. Ozone basically is 3 oxygen atoms that are bonded. And for some reason, you know, we all live by oxygen, but you don't want 3 oxygen molecules, from what I understand. It's not good for you. So that'll be our water treatment. And then our water distribution. You know, we're here again. We talked about our piping systems, and we'll have different types of piping. We'll be going to different locations. We'll be using valves and check valves, things like that, to control the water pressure and the direction of the water. So DC pump versus AC pump. So here again, it's the power requirement. Volts times amps is equal to watts. And so watts is what we're looking for. And so, and whether or not we're going to be using DC or AC, watts is watts, volts is volts. One of the things you want to look at is if we're using DC power and going through an inverter and trying to power an AC, and we're using an AC pump. We really got to watch how much power we're pulling out of the energy storage area, because if we're at 24 volts, so if you take 120 volts, which is our standard here in the United States, divide it by 24, that equals 5. So if you're pulling 1 AC amp, you're actually then pulling 5 DC amps out of your energy storage. And so that's the little trick. We'll look at that again when we're actually working on the board. Pump size and horsepower is very important. Some of these big pumps can get up to 3 and 5 horsepower real quickly. And it's 740 watts per horsepower. So that's what you got to look at. So you got to look at what voltage you're using, so that, and that way you know what amps you're using. So volts times amps equals watts. Remember that. Amps, 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 amps. And watts is the constant. It never changes. And so your volts and amps will go up, but the watts will always stay the same. No matter if it's 1200 watts AC, it's still going to be 1200 watts DC. Wellhead versus gallons or liters per minute. And so the higher the head, the less gallons or liters per minute you're going to get. And so here again, this is where we got to pick our well sizes or pump sizes. It's going to be based on the depth of our well, our head, versus how many gallons or liters per minute that you need. And then also we got to look at how many watts that's going to take to get us that required amount of liters based on the depth of our well. Availability, I'm not sure what I'm thinking right there, if it's water or electricity or what the availability is. The local power needs, what kind of power do we have? And then use and purpose again of all our water. So single phase or 3-phase pumps. Pump size dictates energy need. So if you need a lot of water and you're pumping at any kind of depth, you're going to be going to AC and 3-phase pumps. You know, they're going to be able to push a lot of water to the surface for a village or city. And so that's one of the things you got to look at. Single phase can be 1 or 2 bus bars. We call those legs on our electrical panels. 3-phase is going to be 3 bus bars or 3 legs inside the electrical panel. And then start capacitors are going to be necessary on our AC pumps. The problem that we have is when you have that much head pressure, the capacitor is going to make sure that we have the right amount of electricity until we can get that motor turning in the pump, because that's when we're trying to push a lot of water straight up, we need that. And then we can have backflow preventers inside our water pipe, so that we always have water inside the pipe. So we're not trying to push up through an empty pipe. We got to know the amps per leg. And so if you need 24 amps and you got 3 legs, that's 8 amps per leg. And if you need 24 amps, you only got 2 legs, then that's 12 amps per leg. And so you can see the amperage goes way up per leg. And so a lot of times you want to try to keep the amps per leg as low as possible. And then here again, we talked about gallons per minute is going to, or liters per minute is going to determine your pump size. We have a relatively small pump for this project, just because it's a demonstration. And so we'll see how it looks. And then we have gallons per minute, and then that's going to determine our energy needs. Okay, so we have the pump size and our gallons per minute. Pump size being horsepower, and then gallons per minute is how many gallons or liters we need per minute, per hour, per day, per week. You know, you can spread it out quite a bit. Since we're using solar, we're only going to have 5 hours a day, which where our pump will be working. And so we have to design a pump that's going to get us all of the water we need in 5 hours. And we can have maybe a backup pump or something like that. This is another reason for the energy storage. Once that energy, not energy storage, but water storage, once that water storage, the cistern is full, you always have a reservoir of water sitting there in case you have low sunlight during the day. You can always go back to your storage and have that for your backup water needs. Above ground cisterns. And why do we need above ground cistern? A cistern is a water storage container that we have here. That's what we're going to be using. Construction, they're made out of plastic, they're made out of steel, they're made out of masonry. The one that we're going to be using is an ABS plastic. It's a water reservoir tank. And so what it does is you always have backup water. You have a reservoir of water that you have stored in a tank. Our particular tank is 500 gallons. That'll last, a family, a couple of days. Water storage requirements, that's going to determine the size of the tank. And then the water treatment, how are we going to treat this water? How are we going to purify it? And we have ozone, which is what we had talked about earlier. UV is how you make ozone. And so you can treat the water just by running it through a tube that has ozone next to it, and the ozone purifies the water. Or you can create ozone by running just straight air over a UV tube, and the UV tube basically fries the air and makes the oxygen atoms bond to each other. And then chemical will be like chlorine or some other chemical that's used for purification. Water distribution, here again, that's going to be our piping system. How far are we going to be pumping this water? How far is our distribution system? If it's pretty far, we're going to have some larger pipes. The smaller the pipe, the greater the pressure. And so we want to make sure, and the larger the pipe, the greater the volume. So we want to make sure volume and pressure is where we need it. So we're going to have to design our system so that we have both volume and we have both pressure, okay? And so we have water pressure builders. We have, like I talked about before, we can use the gravity tanks, or we can use a pressure pump with a pressure tank, which is what we're going to be using on this system. But also our water storage will create pressure on its own. So there's different types of schemes, there's different types of designs, there's all different things that we can do. And then also one of the nice things about having a storage tank is you can have a float switch. The float switch will determine how much reserve capacity you have in that storage tank. And it also will control the pump coming on and off. And so if you need a continuous need, you want to make sure that your pump keeps the storage tank full all the time. And then you can also be pulling your water out at the same time that the pump is filling up the storage tank. And so you want to make sure that the storage tank always stays full, but at the same time, making sure that everybody has all their water needs fulfilled. And so all this gives you kind of peace of mind of everything that's going on. That's another reason for the water storage. Surface pumping. So basically, surface pumping is where we're going to be creating our municipal water supply. And so this is where we will have our water piping distribution network. And so the water pump distribution network can be going, it needs to be basically underground where it's nice and protected. And, but it'll be going to all the end users. It'll be going to residential homes, it'll be going to bathhouses, it'll be going to livestock areas. It'll be wherever water's needed, that's where it'll be going. And then here, this is where the surface pumps come in. They maintain the flow of the water and the pressure through the pipes. And then the pressure pumps and pressure tanks make sure that that water is always pressurized. And we're going to try to keep everything right around 50 PSI in our system that we build. and hopefully when we go to test it after we finish building it, everything's working properly. That's where we talk about the water pipe pressures and the schedule. So we have 40, Schedule 40 and Schedule 80 are the two different types of piping that we use here in the United States. Schedule 40 is good for up to about 200 PSI. Schedule 80 can go much higher to 300 to 400 PSI. And then also we're going to have some of our piping to be above ground, and then some of our piping will be buried or underground. One of the nice things about being buried, you have natural weatherization. Here in Texas and San Antonio, we got down to 7 degrees Fahrenheit. Don't ask me what that is in centigrade. But it got cold, and it stayed like that for a whole week. I lost every single pump I had, shattered because they froze. And so even though the sun came back out and the temperature got above freezing, it still took 3 weeks to repair all the damage and get all the water back up and running to all the different areas where we needed water. And so the water is a community resource. It's there for the use of the community, for the use of all the people. And so we've got to make sure it's a very good system with very little maintenance and properly built, and with an attention to detail and good workmanship. So we want to make sure we have a nice water system that we build and finish. Here again, pressure pump, pressure tanks. Our water network needs to be pressurized, and at least here in the United States. Like I said, we use both gravity and we use mechanical pumps to pressurize the water. And you want a continuous pressure. And like I said, our continuous pressure will be at 50 PSI. And then you have a pressure tank. Just like the float switch regulates the amount of water is in the storage tank or the cistern, we're going to have a pressure switch that's always looking at our distribution network and looking at the pressure that's in that distribution network. And if the pressure drops below a certain set point in our piping, then the pressure switch tells the pressure pump to kick on and raise that pressure back up. And so here again, it's a way to, the pressure switch protects all of our pumps by not allowing them to run 100% of the time. They only kick on and off when needed. And so it makes the pumps last a whole lot longer. And so the pressure switch sends that signal to the pressure pump to tell it when to kick on and when to kick off, and build that pressure back up to where it's a manageable pressure and keep the water flowing through there. Our power sources, now we have solar, and we have fuel cell, which is what we use on microgrids here in the United States, and we have energy storage. And so we'll be building our own little microgrid. We actually have a fuel cell and a couple other things. It'd be nice if we can actually hook them up. We're going to be running our pressures on our water, like we had talked about before, between 30 to 50 PSI. And what we're looking for is the stability of our water network. And we're looking for reliability of our water network. And so professional workmanship is what we're going to need. And that's why we have stored gallons of water, and we have pressurized water. So it can go through the distribution system and get everywhere it needs to get in our village. And so also here again, you know, with stored water, you can sanitize your water system. Water storage and purification is determined here again by local needs. Is there going to be a micro or macro water distribution network? Are we going to just come straight up out of the ground and just go straight into a animal stock tank, what we call them, stock tanks for animals, cattle and goats? Or is it going to be a macro water distribution network where it goes all over the village? Potable water is what we drink, And then the non-potable water is what we can give to the livestock. Groundwater contamination, we got to really watch out for that. One of the things where we're going to be drilling, nitrites is huge in the area, and what causes it is causes the nitrite issue is fertilizer. We're in an agricultural area, and so there's a lot of people fertilizing their crops, and that fertilizer gets down into the water table. And so I already had the water tested, and it does have quite a few nitrites in it, but they say the nitrites shouldn't hurt me. So we'll find out. You know, you can come back in a couple of years and see if I'm still look the same. Human health and safety is what we're looking for mainly in any water system. Not only for when we finish the water system, we're drinking the water, but during the construction, okay? So we're gonna be looking again for chlorination, ozonation, UV sterilization, and then we need to look at filtration. We need to get the sediments out, and then we wanna look at using the charcoal filters and then reduce the amount of bacteria and viruses. So I think that brings me to my last slide on this particular PowerPoint. And so what we always say, you know, drink up and enjoy the water. And so I'll see you here in just a little bit for session 2. And session 2 will be up here in just a little bit. So talk to you guys.